Network topology refers to the layout or shape of connected devices in a network. In other words, it tells us how different nodes in a network are connected to each other and how they communicate with each other. Networks must be arranged in a particular way in order to work properly. These arrangements are based on the network hardware's capabilities and the characteristics of the various modes of data transfer. The topology refers to the actual physical organization of the computers on a network. Topologies vary depending on cost and functionality. There are 5 basic network topologies, which are named as follows: bus, ring, mesh, star, and tree. Each of these topologies has their advantages and disadvantages, as we will discuss in the next slides. Bus topology. The basic form of a bus topology is simply a case of running a linear cable from the first PC to the last PC in the network, and then add further devices to which all network devices are directly attached. The main cable is called the bus. It uses a multi-drop transmission medium where all nodes on the network share a common bus and bus share communication. This allows only one device to transmit at a time. Advantages of the bus topology. It can easily be expanded to include more nodes by just extending the two endpoints of the main bus. It allows high rate of data transmission compared to other topologies. It is simple to install. It is relatively inexpensive and uses less cable than other topologies. Disadvantages of the bus topology. It does not cope well with heavy traffic rates. No redundancy, as if there is a break in the main cable, the entire network goes out of operation. It is difficult to identify the problem when the network is down. Performance degrade as additional computers are added. Ring topology. A ring topology is an architecture that consists of a series of devices connected to one another by unidirectional transmission links to form a single closed loop. Each device is connected directly to 2 other devices, one on either side of it. All messages travel through a ring in the same direction, either clockwise or counterclockwise. However, a failure in any cable or device breaks the loop and can bring down the entire network. Ring topologies are relatively expensive and difficult to install, but they offer high bandwidth and the network can cover a longer distance than bus topology. Advantages of the ring topology. The ring topology is relatively easy to troubleshoot. A station will know when a cable fault has occurred because it will stop receiving data from its upstream neighbor. It can create much larger network using token ring. Disadvantages of the ring topology. Not fault tolerant. A single cable fault can bring down the entire network. It is also difficult to reconfigure, as one malfunctioning workstation or bad port in the multi-access units can create problems for the entire network. It is expensive because multiple cables are needed for each workstation. Mesh topology. A type of network setup where each of the computers and network devices are interconnected with one another, allowing for most transmissions to be distributed even if one of the connections go down. There are 2 main kinds of mesh topology: full mesh and partial mesh. In a full mesh topology, each node is physically connected to every other node. full mesh is generally utilized as a backbone where there is a great need for fault tolerance, such as the backbone of a telecommunication company. In partial mesh topology, some nodes are organized in a full mesh scheme, but others are only connected to one or two in the network. Partial mesh topology uses fewer connections and, though less expensive, is also less fault tolerant. Advantages of the mesh topology. The mesh topology provides fault tolerance by having separate cables for each connection, allowing any one cable to break without interfering with the rest of the network. A bad link may go unnoticed because network will still operate even if a cable goes wrong. Computers or network devices can switch between these multiple redundant connections if the need arises. The principal disadvantage of the mesh topology. Total installation costs can be very high because of the large number of cables. A mesh topology can quickly become quite complex as wiring and connections increase exponentially. Star topology. Each computer in a star topology is connected to a central point by a separate cable. The central point is a device known as a hub. Although the setup uses more cable than a bus, a star topology is much more fault tolerant than a bus topology. This means that if a failure occurs along one of the cables connecting to the hub, only that portion of the network is affected, not the entire network. A single cable failure won't bring down the entire network. It also means that you can add new stations just by running a single new cable. Advantages of the star topology. Most network designers prefer the star topology because these topologies make it simple to add network devices without disruptions to the network. It is also easy to detect faults and to remove parts, as each device has its own cable. New stations can be added easily and quickly. Disadvantages of the star topology. The star topology is susceptible to bottlenecking and single-point failure because all the nodes rely on a single connection device, that is, the hub. Total installation cost can be higher because of the larger number of cables, but prices are constantly becoming more and more competitive. Tree topology. A tree topology is a combination of bus and star topologies. It is identical to the bus topology, except that branches with multiple nodes are possible. In this case, nodes are connected in groups of star-configured workstations that branch out from a single route. That is, it connects multiple star networks to other star networks. The root node usually controls the network and sometimes the network traffic flow. This topology is easy to extend. When new users need to be added, it is simply a matter of adding a new central connection device. Advantages of the tree topology. This topology is easy to control. The root provides centralized management and monitoring. Disadvantages of the tree topology. No fault tolerant, as if the backbone cable breaks, the entire segment goes down. The tree topology is difficult to configure, wire, and maintain, especially in extensive networks. In this section, we have looked at the physical organization of the network devices in the topologies. However, we have not looked at how data is transmitted among the network devices. This part is discussed in the following section, and it refers to logical topology, indicating how data flow in the different physical topologies mentioned above.